Okay, in this video, I want to show you how to calculate the pH of a solution made with a salt. So rather than a true acid or a true base, I want to show you how to calculate for a salt, because salts may be acidic, they may be basic, or could be neutral. So in this example, we need to find the pH of a 0.250 molar sodium acetate solution. And acetic acid has a Ka value of 1.8 times 10 to the negative 5 at 25 degrees Celsius. Okay, so this is the Ka for acetic acid. Now, the sodium ion here, this Na+, sodium ion doesn't have acidic basic properties. It's a neutral cation. So what we're looking at is the acetate ion mixing with the water in solution and then coming back or recombining with the hydrogen to create acetic acid molecules and the hydroxide ion. Okay, so this salt is going to generate OH ions in solution, which helps us recognize that it's going to make the pH greater than 7. It's going to be in the basic range. So what I want to do is set up an ice table, because acetic acid, acetate, that's our weak acid base conjugate pairs. The initial molarity 0.250, 0, 0, minus x plus x for the change as the equilibrium is established, and gives us an equilibrium value of 0.250 minus x and x and x. So our Kb expression here is x over 0.250 minus x. Okay. Now, I am focusing on a Kb rather than a Ka because of the OH ions here. This is going to be working as a base. So I'm going to focus in on Kb. So let's take Kw, 1.0 times 10 to the negative 14, divided by our Ka, 1.8 times 10 to the negative 5. That gives us our Kb. Okay, so we have 1.0 negative 14 divided by 1.8 exponent negative 5. And we get 6.0 times 10 to the negative 10th. Okay. So, again, how I did that is I went 1.0 exponent negative 14 divided by 1.8 exponent negative 5. Oh, yep, it rounded a little bit. I don't want it to round. There we go. 5.55 times 10 to the negative 10th, again, is our Kb. Now we're going to put Kb in 5.55 10 to the negative 10th is equal to x over 0.25 minus x. Now I'm going to do the 5% approximation on this so that I don't have to run the quadratic equation. I'm going to ignore this point or this minus x and solve so that I can see what x is. Then I'll look and see if it's under 5% so that I can safely make this approximation. So times 0.25, I get 1.38 times 10 to the negative 10 equals x squared. Then let's square root it. and we get 1.1785, so 1.18 times 10 and negative 1, 2, 3, 4, 5. Okay? And this x that I'm looking at, the change, is far less than 5% of 0.250, so I'm going to have that be valid. So x now can be equal to the OH concentration. So I can run a POH. Okay, so negative log, oops, no, let me just type it in this way, 1.18 exponent negative 5 log and then negative 4.93 is my POH. Okay, so my pH is then equal to 9.07, because remember that's 14 minus POH. Okay, so far so good. And I've got my pH here at 9.07. Okay, showing in the basic range.